a couple applications of linear data sets. The first one involves the speed of a falling object some seconds after its release. And it says, show that this data can be modeled by a linear function. Now, the easiest way to do so would be to go to technology, either Graphing Calculator or Desmos.com. And we want to just add a table. And put our data in. Okay. Our data looks like it may be linear. What we'll do is type in y equal, we can't use equals here, we have to use tilde in this program. x1 plus b. As you can see, it actually is perfectly linear, this data. It's got an R correlation coefficient of 1, and it gives us the slope and the intercept. Now, one thing we're going to want to do with this, though, is we do want the letters used, the variables used, to reflect the situation. So instead of using y and x here, I want to change my columns to being t and v. V is the dependent variable. The speed depends on how long the object has been released. And we want that dependent variable to be the output of the function. And we'll just change our equation now to v equals mt plus b. That would be more appropriate for the situation. But anyway, we do get the slope from the program and the intercept, and that's all we need in order to write the general equation of the line that models this data. So, go back to our problem. M equals 12.16 and B equals 0. So, we want to use the form v as a function of t equals mt plus b. By plugging in our values of m and b, we get this. V of t equals 12.16 t. Nice. The next one relates temperature in kelvins to temperature in degrees Fahrenheit. They're different scales, different ways of measuring temperature, but we believe they may have a linear relationship to each other. Well, in fact, they do. So, let's go ahead and find out what that linear relationship is. Create a new table. Let's change our variables to K and F. Okay, I don't see the data yet, so I better zoom out. Okay, there it is. Alright, now let's plug in the formula. And in the original question, they said, show that the temperature F is a linear function of the temperature K. So they want K to be the input and F to be the output. And that's what we have here. Typically your input goes on the left, output goes on the right. And there we go. It's perfectly linear because the R is 1. And we have the M and the B. So now let's go back and write our equation. Okay, so we'll do F is a function of K equals M times K plus B. All right, let's plug it in. That's a negative 459.